Yes. So let me see, guys, if I am live yet. Just give me a moment and let me check. I can't see myself live right now. Just give me a moment and yes, I am live. Now I can see myself. Great. Cool. So I am live and let's see who all are here. Okay. So yeah. Hi guys. So we are here at Unacademy platform in which we are going to ace your exams with Unacademy. Definitely. Right. And this is a session for class 11. Just, yeah, now it's perfect. Cool. Now it is perfect. Now I can teach you easily. Cool. So, yes, guys, my name is Kirti Sharma and I am your chemistry educator on this platform. Yesterday, we had a session of class 12 that was your introduction to redox reaction. Today is your session of class 11 in which we are going to discuss, you can say, the introduction to chemical kinetics. That's what we are going to discuss right now. Very easy chapter and quite interesting as well. I hope that some of you might have attend the class on the like special platform as well. If not, then you can just check it out. And Chali, let's get started with this. Right now, we don't have many students, but it's okay. I guess they are going to watch it in the recorded session. So let's get started. Let's see. All right. Yeah. So, welcome to the class, and I am your chemistry educator. As I discussed, I completed my graduation from University of Delhi, and I have, you can say, more than 5 years of teaching experience. So, that was like my brief introduction for now. Let's see if there is any comment. Not right now. Okay, cool. Then we can get started. So, what are we gonna do today? What are we going to study today? That's your chemical kinetics. What are we going to study today? Bache, this is chemical kinetics. Chemical kinetics. All right. And a good news for you that on Unacademy platform, the very first thing, if you are very new, you have not used Unacademy app earlier, then the first thing which I would suggest you is to like simply download the Unacademy Learner app and just go to ISC or ISC and ICSE boards for class 11 and class 12. There in that particular category, I'm there, the very basic thing, and you can unlock my free live class. I'm repeating it again. You can unlock my free live class, which is also termed as special class because they are free for everyone. But you need to unlock them. So you can unlock them by using my code. My code is KSIS10. KS stands for Kirti Sharma, IS because this is ISC boards, and 10 because इसका reason कुछ और है. The reason is quite different. The reason is that if you get plus subscription, you will if you apply this code while getting the plus subscription, you will get additional 10% discount, or you can say 10% off. So this is a lightning deal for you, I can say. And okay, then let's get started. Let's begin our class. So before that, follow Unacademy champions on Telegram. So the link is in the description. You can simply join it. All right. You can simply join it. So let's get started and subscribe to us on YouTube right now. For now, we have a small target in which you are going to help us, and that is only of 1,000 subscribers for now. I'm waiting like as soon as you can cross this number. So that is only 1K subscribers. That is only 1K subscribers. So let's get started with our chemical kinetics. As you can see, this scientist uncle, this is our chemical kinetics. So okay, you cannot see the kinetics part. You can just see, you can see to A only. So this is your chemical. Let's do this. This is your chemical, and right here. Give me a moment. Yeah. And here we can write kinetics. Let's write it in small. Chemical kinetics. Okay. Yeah. The where the kinetics is written, I am over there, right? Okay. So cool. Let's get started with our chemical kinetics. So the very first question which arises is, ma'am, since we are studying chemical kinetics, so the very first thing is, ma'am, let us know what are the applications of chemical kinetics, right? Like the very basic thing which I always feel is that students don't know the applications, the uses of whatever we are studying. All right, they always say, ma'am, I have never used it in my daily life. Arey Baba, you see it, you use it all the time in your daily life. Like whatever you are studying, these are very basic things, okay? Very basic, trust me, okay? So, chemical kinetics, let's talk about what is chemical kinetics, and then we'll talk about its application. Like how are we using it, when are we using it, and who is using it. All right. So, when it comes to chemical kinetics, it simply means that it is a branch of science that deals with the rate of the reaction. It deals with the rates of the chemical reactions. Now you will be like, ma'am, what are rate? What do you mean by rate? Like, I talking about the prices? No, I'm not talking about the prices, but here rates of chemical reactions. It simply means that I am talking about the speed of the chemical reaction. I'm talking about what? I'm talking about the speed of chemical reaction. Like, is it happening very fast? So it's a like fast reaction when the speed is very fast. If your reaction is happening at a slow rate, बहुत धीरे धीरे आपका रिएक्शन कंप्लीशन की तरफ जा रहा है, then it is your slow reaction. And what is a moderate reaction? When your reaction is proceeding at a moderate rate, not too fast, not too slow. So that's a moderate reaction. We will discuss in detail what are these three kinds of reactions are. So the speed of chemical reaction. That's what we mean by rate of chemical reaction. So the rate of chemical reaction simply means the speed of the chemical reaction. Now, where are we using it? In our industries, basically we are using it. How? Because suppose if you want to set up a factory in which you want to produce a chemical compound, say ammonia. Say what? Say ammonia. Now you need to know, now you know what are the things. You need nitrogen gas, you need hydrogen gas. That's the process that you can get ammonia. Very simple process, okay? But don't you need to know the time of the reaction? Like how much time is it going to take when you mix all the reactants? Like what is the time span, whether it is within the seconds or it takes a day or two, it take a month, it can take a 6 month, it can take a year, it can take a million of years. Like what is the time? That is something which you need to know, right? If you think that all the reactions happen within, like, you just snap and your reaction occurs, no, it doesn't work this way. If it works this way, then you can just simply take coal and you can convert it into diamonds. That's a chemical process. No, do it in a lab, be a millionaire. But can you do that? There are multiple constraints. The very first constraint is that you cannot convert coals into diamonds by yourself, because it takes millions of years to complete that process. How many years? Millions of years. So you can't do that. And the another thing is, it happens in a very, like, particular conditions. Very high temperature, very high pressure. Only then that reaction would take place. Otherwise, it won't, right? So you cannot set up those kinds of conditions in a lab. You can't. And you can't just like take millions years to like proceed for a reaction, right? So that's a reason. So that's how you need to know the time which a reaction will take in order to complete. So that is a very, basic thing, I must say. And another thing, like all the processes which are happening around us, you can say whether it's rusting or aging or photosynthesis and everything, all are like represented by with the use of you can say a chemical equation, right? And to know whether that reaction will take place or not, this is something different I'm talking about. Whether the reaction will take place or not, this is something different which you have studied in thermodynamics with the help of delta G, that is your Gibbs free energy. In that chapter, you studied whether this reaction can happen or not, right? If delta G is negative, then your reaction is spontaneous. If it is positive, then your reaction is non-spontaneous, right? But right here in this chapter, we are studying about a reaction and its speed. Like, what is the speed of reaction? All right, that's what we will be learning in this particular chapter. All right, so let's see. Simply, we can say that chemical kinetics is the part of chemical science dealing with the study of rates of chemical reactions, number one, and the factors which affect the reaction rates. And what are the different factors, whether it's the temperature or pH or dielectric constant, or you can say the concentration of reactants, or you can say the nature of reactant, or you can say the physical state of reactants. So there are different factors on which the rate of reaction depends, right? Like if you take something in gaseous form, if something, then the reaction is happening quickly, fastly. If you're taking it like in solid state, it is happening at a slow rate, for example, for instance. Okay, so you need to know these factors. Like what are the factors which affect the rate of the reaction, which affect the speed of the reaction. So for now, I have devoted, I guess, a lot of time in trying to make you understand what chemical kinetics is, what is its application, like why are we studying it. This just bothers me so much when a student says, ma'am, I really don't know, like, why are we studying this if there is no use? See, you are studying this because you use it in your even your daily lives. Okay? So that's a very important part of your life, and that's what you should know. That this chapter we are studying, and this concept or this thing is used in this particular direction, or in this particular work. Okay? So that's what you need to know. All right. So I hope that this is okay. No doubts till now. All right. Let's move ahead. Correct. Now, chemical reactions in time. So the goal of chemistry is to understand the macroscopic world by examining the molecular world. In this chapter, we look at how those changes occur with time. ये चीजें कैसे होती हैं, कितने time में होती हैं. That's what we are going to learn in this chapter. That's what we are going to study in this chapter. Okay, since now we are in the middle of the session, do we have? Okay, cool. So let's get started. Let's begin. So the next part is, what are slow reactions and what are fast reactions? So it is a very basic thing, right? Very basic thing. As the name suggests, what would be a slow reaction? We discussed this in the previous slide as well. So what is a slow reaction? A reaction which is happening at a slow speed, which is happening very slowly. Like I told you as well, like rusting is a very slow process, right? It doesn't happen in the way that you took iron, you put it in the moist air, and within some time, like a day or two, or even instantly, the iron is like rusted. No, it doesn't happen. It takes years, right? It is a very slow process. So when we talk about slow reactions, when we talk about slow reactions, so in case of chemical kinetics, in this particular chapter, we are not interested. Please mind it that we are not interested in slow reactions. We are not. Okay. Now, let's see what is written over here. The slow reaction is defined as the reaction which takes longer time to complete. Quite obvious. That's what we have discussed so far. The slow reaction possesses a low rate of reaction, yani कि a low speed of reaction. Obviously, this we know. They possess higher activation energy. Now, you'll be like, ma'am, what is activation energy? So I have something for you regarding activation energy. So, activation energy is the minimum or the least amount of energy which is, you can say, which is required by the reactants in order to complete the reaction. So what do I mean by in order to complete the reaction? I mean for reactants to get converted into products. For reactants to get converted into products, I need this reactant. I need this reactant to have a least amount of energy, a minimum amount of energy, a minimum amount of energy. Why do I want that? I want that so that the reactants can be converted into the products and our reaction is proceeded, right? So it is the least amount of energy required to energize or activate the molecules to proceed the reaction. The exothermic reactions and endothermic reactions possess different activation energies. Now, if you forget, what are exothermic reactions? In which there is an evolvement of heat and light, you can say. In which there is an evolvement of heat and light. All right, just give me a moment, guys. Hmm. Right. So that's your activation energy. So they possess higher activation energy. The example of slow reactions are rusting of water pipe. This we discussed, the rusting of water pipe, a piece of newspaper turning yellow and so forth. You must have seen oftenly that the old newspapers, or you can say the old notebooks, if you look at them, old books, old notebooks, old newspaper, they must have turned their color yellow from white. They must be yellow, they must be white in like beginning, but with time, with years, it becomes yellowish, right? If you look into like your college or school library, you will see, you will notice that the old books would have yellow pages, right? So it is also a chemical reaction which is happening at a very slow rate, at a very slow rate. So a piece of newspaper turning yellow and so forth. The fast reaction is defined. Now this was about your slow reaction. Now this is about your fast reaction. So the fast reaction is defined as the reaction which takes shorter time to complete, the one which takes the lesser time to complete. The fast reaction possess high rate of reaction. Quite obvious, जो reaction जितना तेज है उसकी speed उतनी ज्यादा होगी, right? So it would have a high rate of reaction. They possess smaller activation energy. Ab Now, what happens in case of fast reactions? They have small activation energy. In case of slow reactions, they have higher activation energy. So we are comparing, okay? The example of fast reactions are striking a match. The moment you strike a matchstick, it gets lit instantly, right? तुरंत जल जाती है. They possess, sorry, burning of petrol, a very rapid reaction, I should say, a burning of petrol in the car engine and so forth. So these are the example of slow reactions and fast reactions, and I have made you understand what slow and fast reactions are, right? And now we did slow reactions and fast reactions. Fast reactions. So for now, we are not interested in either slow reactions or in fast reactions. We are not interested. I've just made you understand what these are. Then we will be like, ma'am, then in what kind of reaction are we interested in? So, beta, we are interested in the moderate reactions. We are interested in the moderate reactions. Now, what are moderate reactions? The reactions which are neither too fast nor too slow. So we are only interested in these kinds of reactions. We are only interested in these kinds of reactions. Okay, just give me a moment, guys. Okay, so we are only interested in moderate reactions, जो कि moderate speed पे होते हैं, which take place. Let's write. What are moderate reactions? Can you see it here? You can't. Okay. So let's write what are moderate reactions. What are moderate reactions? So moderate reactions are which are neither too slow nor too fast. So these are what? These are the moderate speed reactions. Hi Shreyansh Raj. Hi bache. How are you? So in which class are you in? In which class are you? Shreyansh Raj. Okay, that's a very good name. I like it. So since now we have studied what a chemical reaction is, what is chemical kinetics, what are its applications, slow reactions and fast reactions, okay? All right. Shreyansh, if you belong from ISC or ICSE boards, then quickly share this session with your friends so that there'll be awareness that this ISC category has come up, okay? So that we can all study together. Propagate it as much as you can, guys, okay? And if you have not downloaded the Unacademy Learner app, then you can just simply download it. You can unlock free live classes. I'm telling you again that you can unlock free live classes. You can unlock free live classes. It is free for everybody. It is free for everybody. And how can you unlock it? You can simply unlock it by using my code, and my code is KS, because my name is Kirti Sharma, KSIS10. Okay, so you can unlock free live class. And what else can you do? You can, if you get plus subscription, if you get plus subscription, so in that case, you will get additional 10% off by using this code. You will get 10% discount instantly. You will get 10% discount. Okay. And propagate it within your friends, family, cousins, schools, within your WhatsApp groups of your classes and stuff. You can just share the session so that we can all be together. All right, guys. All right. Let's get back to the this we have done activation energy, exothermic, endothermic reaction. Okay. Now let's look at the rate of reaction. When it comes that we want to define the rate of reaction, what do we want to do? We want to define the rate of reaction. I will make you understand this concept with the help of speed. And speed of what? Simply speed of car. Simply, if I say speed of car, how do you define that? Speed of car. Simply you say, ma'am, the distance you travel. You say what? Ma'am, simply the distance you travel over the time you took in order to travel that distance. That's how you can calculate the speed, right? That is how you can calculate the speed. No issues. That's what we have done till now. Now, let's talk about the average speed. Let's talk about the average speed. Average speed of car. So what do you say? Ma'am, total distance traveled. Total distance traveled over total time you took in order to travel the distance. That's your total distance over total time. Okay, so you cannot see. It's total distance over total time. Let's write on the left side. Okay. So if I measure distance by say x and t by time, okay? So what do I say? Total distance. How do I calculate the total distance? Final minus initial, right? So I say x2 minus x1, correct? Over total time, final time minus initial time, t2 minus t1, right? So I can write it as delta x over delta t. That's how you define speed. As simple as that. You write delta x over delta t. If I tell you about instantaneous speed, if I tell you about instantaneous speed. So what do you do in case of instantaneous speed? You say that, ma'am, what can we do? Just give me a moment. Yeah. Yeah. So what do we do in case of instantaneous speed? You say that, ma'am, when this delta t, when the time approaches to zero, when the time approaches to zero, when it just became the a moment, एक पल बन गया वो, when this delta t approaches to zero. So then this delta is denoted by simply d, right? Hi Gunja, Jais. Okay, hi Shweta. What's up, bache? How are you? Yeah, I got you, Shweta. How are you? So this is your instantaneous speed, right? When this delta t approaches to zero, then your delta becomes d. So it becomes dx over dt. So that is your instantaneous speed, right? Great, bacha. Okay. Now, we'll do the same thing with rate of reaction. With rate of reaction. Now, how do we measure the reaction rate? How do we measure it? Let me tell you the quantities in which we can measure the reaction rate. If I write measuring the reaction rate, if I say measuring the reaction rate, so I can measure the rate of the reaction, the speed of the reaction. The very first thing in which we are going to deal is number one, which is concentration. What is it? It is concentration of reactants or products. Concentration of reactants or products. Right? Quite obvious, no? If a reactant A is getting converted into the product B, so quite obvious the concentration of A will decrease and the concentration of B, means the concentration of product will increase. Quite obvious this is. So the concentration is the very basic thing in which we will be dealing. Okay, concentration. What can be the other things by which we can measure the reaction rate? पहला तो हो गया concentration. The very first one is concentration. Apart from it, what can we take? What else can we take? You can also take color change. You can change, you can say color change. Okay. Number 3. What else can you take? In case of gases, you don't define concentration, you define what? You define pressure. You define pressure. So pressure change भी एक चीज हो सकती है. Pressure change can also be taken. Or else, what can you take? pH change. If the pH level changes, even then you can measure the rate of the reaction using it. Or you can say temperature change, volume change. By these factors, you can also measure. Pressure change, volume change. These can also be taken, right? So these are the factors, okay guys? So now let's take what? Now we'll be taking concentration in order to get the rate of the reaction, okay? In order to get the rate of the reaction. So how do we define? Now let's see. You can say that rate of reaction is simply, it is simply change in concentration. The way in the speed of car, we saw what? Change in distance. But in this case, we are writing change in concentration over change in time. What would we take? Change in concentration over change in time. That is, this is what your rate of reaction means, right? Now this change in concentration would be simply C2 minus C1, and this change in time will be T2 minus T1, right? So this becomes your delta C and this becomes your delta T. Change in concentration over change in time. Now, this is what? This is your average rate of reaction. This comes out to be your average rate of reaction. Alright. But if we want the instantaneous rate of reaction, if we want instantaneous rate of reaction, it means you want to know the rate of the reaction at a particular instant, at a particular moment. Then you will be needing instant rate of reaction. And what happens even in case of like instantaneous speed? The speedometer of the car. The speedometer of the car shows deflection instantly the moment you accelerate your vehicle, right? That's how it works. So that's your instantaneous speed at that particular moment. Similarly, this is your instantaneous rate of reaction. It means in that particular moment, what will be the rate of reaction? So what you do is, in this delta C by delta T, in this delta C by delta T, if this delta T, like if time approaches to zero, कि आपने टाइम इंटरवल को इतना छोटा कर दिया such that this change in time becomes just a moment, right? So it becomes, you replace delta by d, so it becomes dc over dt. So it becomes what? It becomes dc by dt. That's your instantaneous rate of reaction. Okay, you can write a note here, and the note is that rate of reaction is always positive. Please note this, that rate of reaction is always always positive. It is always positive. I have highlighted this so that you will remember. So the rate of reaction is always positive. Okay, I hope that there is no problem till now. All right. Is there anybody saying something? Let me check. Okay, cool. So I guess we can go ahead. Even for the students who watch this session in recorded form, let me know if you guys have any doubt. You can connect with me on Unacademy app as well. I told, maybe I didn't tell you. Okay, so my username is Kirti underscore Sharma. Kirti underscore Sharma 1223. And this is my username almost everywhere. You can connect with me on Unacademy app with this username. Okay. And if you are planning to get a subscription or to unlock a free live class, then you can use my code, that is KSIS10. Since this is a new initiative, a new category, so you are the one who can promote and propagate these sessions so that we can all study together. Okay, so that would be the best part. And by using this code, you may get additional 10% off. You will get additional 10% off. Okay, cool. Now let's move ahead. Now, if I say, let's take a hypothetical reaction. Let's take for a hypothetical reaction, if I say, for a hypothetical reaction, and the reaction is A changes into B. A changes to B. Now, A is the reactant and B is the product. Okay. So, as the reaction will proceed, the concentration of A will decrease and the concentration of B will increase. This is quite obvious. This is what we have discussed. Also, what will happen? The A will disappear. क्या होगा? What will happen? A will disappear and B will appear, right? And B will appear. Correct? So we say that rate of disappearance of A, meaning the speed at which A is disappearing, will be equal to the rate of appearance of B, means speed of like appearance of B. So we say that disappearance of A, we say that disappearance of A will be equal to appearance of B. It will be equal to appearance of B. All right. Correct. So how do we define that? How do we say that? So see, whenever you whenever you want to write rate, I should write rate of disappearance of A will be equal to rate of appearance of B. Okay, this is the full statement. This is what we have got. Now, how can we do that? In case of a reactant, we write the rate of disappearance as, we will write it as minus of dA by dt. Rate, this is the rate we are writing. Now you'll be like, ma'am, why are you applying this minus over here? Why this minus? So this minus is here because, see, dA by dt, how do you do that? Like, basically final minus initial, it is final minus initial concentration. So in case of reactant, final minus initial will be negative, and I told you that rate can never be negative. Rate of reaction is always positive. So in order to make the rate of reaction positive, we added a negative over here. We added a negative over here. Okay. So minus of dA by dt will be equal to dB by dt. It will be equal to plus dB by dt. This is plus and here this is minus. So this is how we write that rate of disappearance of A will be equal to rate of appearance of B. All right. Is that clear? Now one more thing which we need to care of. Like says this was a very simple hypothetical reaction. We need to take care of the stoichiometric ratio as well. See, here both the sides it was 1, 1. That's why, okay, let me make you understand with the help of another example. Okay, if I write for another reaction, let's take another reaction. For another reaction, if I say the reaction is, say, 2H2O2 gives you 2H2O plus O2. See, this is your reaction. Okay? If I tell you to write rate of disappearance of H2O2, rate of disappearance of H2O2, how would you write? You will say, ma'am, minus dH2O2 by dt, right? Minus dH2O2 over dt. Now write the rate of appearance of H2O. If I say to write rate of appearance of H2O, so what would it be? I hope you guys can see it. It will be plus dH2O by dt. Correct? This is how it would be. Now why did it happen? Because again, see, the stoichiometric ratios of H2O2 and H2O is same. The you can say the rate of disappearance of H2O2 will be equal to the rate of appearance of H2O, right? But the rate of appearance of O2 will be half of the rate of disappearance of H2O2, right? See the stoichiometric ratios. Here it is 1 and here it is, sorry, here it is 2 and here it is 1, right? So the rate of disappearance of we can say that the rate of appearance of oxygen will be half of the rate of disappearance of H2O2. Correct? So this is something which we need to take care of. Okay? So from this we can say that, yeah, say what can we say? We can say that minus D H2O2 by dt will be equal to plus dH2O by dt. That's what we can say, right? That's what we can say. Is that okay? Or इसी को what can we say as well? That we can say that 2 times dO2 by dt. This is also we can write. That's what that statement means that we were writing, right? Correct. So is that okay, guys? I hope it is okay. So for any, this we have covered. So general expression for rate of reaction. See, if this is your general chemical reaction, what would be the rate of reaction? I'm telling you the way. So it will be, if we talk about our rate average, if we talk about the average rate of reaction, so you write it in a way, minus 1 by small a. Minus because it is on the reactant side, minus 1 by a dA by dt. Please remember this. Now we are writing the rate of the reaction. Okay, the whole reaction. This is the rate of the reaction. All right. So minus 1 by a dA by dt. Now since this is written under the square brackets, maybe we didn't discuss it earlier, but whenever you write something under square brackets, it means that you're talking about its concentration. You are talking about its concentration. So minus 1 by a dA by dt will be equal to minus 1 by b dB by dt, and this will be equal to, now it would be minus 1 by minus 1 over small c, or plus 1 over small c. It will be plus 1 by small c over dC by dt. What else can we write? We can write plus 1 by d by dt. Okay, so we did something what? This is not this is not average rate, bache. This is your instantaneous rate. Sorry. This is your instantaneous rate. All right. Is it okay till now? Any any problem right till now? I hope that you guys understood. Right? So this is a way to write the expression. In the tomorrow session, we will do some questions as well regarding the rate of the reaction. We will begin the class with questions. Okay. Now comes the next part, which this is the factors affecting the rate of chemical reaction. This is what? This is the factors affecting the rate of the reaction. Means what are the things by which, like, your reaction rate, the speed of the reaction uh, gets changed. These are the factors affecting the chemical reactions. So it is the nature of reactant, like whatever is the nature of reactant, it depends on the nature of reactant. It depends on the concentration of reactant. Okay, it depends on the concentration of reactant. टेम्परेचर पे डिपेंड करता है, the fact the rate of reaction, whether the reaction is happening slowly or very quickly. It also depends on the temperature. Surface area of the reactant. Fifth is radiation. And what else can we add? It also depends on the pH of medium. pH of medium we can add into it. And what else? the dielectric medium, the dielectric constant of the medium, dielectric constant for the medium of medium. These are the factors affecting. What else? A very important one is the presence of catalyst, right? A catalyst can be added in order to, you can say, speed up the reaction, or maybe to slow it down. Catalysts are also used to slow down the reaction. So the presence of catalyst, a very important one, right? So it depends the rate of chemical reaction. So please remember that it is simply the speed of the reaction, whether your reaction is happening slowly, fastly, moderate speed. So that's your rate of reaction. Okay, I guess bache, that is it for the day. Thank you, I should say. Correct. So thanks, that is it for the day. All right, bacha party. If you guys have any doubts, then let me know in the comment section, or you can just simply connect with me on Telegram or Unacademy Messenger as well. My username is, I'm telling you guys again, my username is, let me change this. Give me a moment. Yes. So my username is Kirti underscore Sharma 1223. This is my username. Okay. This is my username. And if you guys are planning to take plus subscription, then simply use my code, that is KSIS10, and you will get additional 10% off. You will get 10% off on your plus subscription. Yes, Piyush, class is finished, bache. You are a bit late. And the another session of redox reactions will be at 10 p.m. today. Okay? Piyush, you can simply like join the Telegram group, bacha. उसमें आपको सारे updates मिल जाएंगे. You will get all the updates there. The link of the Telegram group would be in the description. So just simply join it. You will get all the notifications regarding the class, so that you won't miss any class. Okay? The next session will be at 10 p.m. today. Okay? Yeah. So that is it for the day, beta. I've lost my pen. Okay, bache Piyush, I'll be waiting. And share this session to your friends as well, so that you all will be here. Since it is the beginning and you guys are the only one who can, promote. So do it. For now, our target is simply 1K subscribers. So make it happen as soon as possible. I'm waiting. Okay, that's great. And now we are ending this session. That is it for the day. See you guys at 10 p.m. Don't miss the class. Bye bye.